Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. We are going to solve problem 3.27. So in this problem, you have 10 kilogram of refrigerant 134A filling in a 1.115 meter cube rigid container at an initial temperature of minus 30 degrees Celsius. The container is then heated until the pressure is 200 kilopascal. You need to determine the final temperature and the inner pressure. So first, let's extract the information that describe the initial condition. So initially you have T1 equals to minus 30 degrees Celsius, and then from the volume and the mass you can get your specific volume at the one. This is V over M. So you have 1.115 meter cube over 10 kilogram. This is equals to 0.1115 meter cube per kilogram. Okay, so based on these two properties, you need to find out your pace of the of your system. So next is you refer to table A11. Okay, so I have A11 here. Let's go to A11 and you go to T equals to minus 30 degrees and you get the V sub F and V sub G, because the other property that you have is your V1. So V sub F is equals to 0.0007203 per kilogram, and V sub G is 0.22580 meter cube per kilogram. So next thing that you need to do is to compare these two values with your actual V1 here. So you can see that your VF is actually less than your V1, and this is actually less than your V sub J. So this indicates that your pace, your initial pace, is actually a saturated mixture. Saturated mixture. Okay, so based on that, you can actually get your pressure P1 at which is equals to be set at minus 30 degrees Celsius. Okay, at minus 30 degrees Celsius, and this is equals to 84.43 kilopascal. Okay. All right, the next thing that you need to do is to look at the final state. So now let's go to final state. Final state, what you have, your pressure is equals to 200 kilopascal, and then since it is a rigid container, then we know that our specific volume at final state is equals to the specific volume at your initial state, which is 0.1115 meter cube per kilogram. So now you have pressure and you have the specific volume. So what you do is you go to table A12 to get other properties. Okay, so at P equals to 200 kPa, what can we say about the state of our, or what can we say about the pace of our final state? So let's go to table A12. Okay, I'm going to make it a little bit bigger. So we look at 200 kPa. Let's check on our V sub F and also on our V sub G. Okay, so you take that to value. VF is equals to 0.0007533 per kilogram, and V sub G is 0.099867 meter per kilogram. And again, we need to compare these two values with our actual specific volume. So when you check and when you compare, you can see that your actual specific volume is actually bigger than V sub G. So this means that your refrigerant is actually at a superheated vapor. Okay. So if you have a superheated vapor, what you need to do is you need to refer to table A13. Okay. So let's go to table A13. Refer to table A13. So I have table A13 here. Since your pressure at state 2 is 200 kilopascal, so I go to P equals to 0.2 MPa and I put it here. So we can see what we need to do is we need to find, okay, here is our specific volume, this is our internal energy, this is our enthalpy, and this is our entropy. So let's go to our specific volume and try to find do we have any value that is equal to our actual V2. Okay, so our V2 just now is 0.1115. So if you see here, we don't have the exact value, but we know that our specific volume is actually in between these two value here. So what you can do is you need to do interpolation to get your temperature. Okay, so make a little table. This is my specific volume. So you take that 10 degrees Celsius, and this is your T2, and this is 20, and you bring out that value for the specific volume corresponding to 10 degrees Celsius. This is your actual specific volume, and this is the one that is corresponding to 20 degree Celsius. Okay, all right. So you do your calculation. You take T2 minus 10 over 20 minus 10 equals to 1115 minus 10955 divided by 0.11418 minus 0.10955. So you punch in the values in the calculator, you will end up with T2 equals to 14.21 degree Celsius. Okay, ta-da! All right, that's it for this problem. Thank you. Assalamualaikum.